So, let's talk about a horizontally launched projectile. I want you to know a few things before you start actually trying to solve a problem that will hopefully help you when you are sitting down to read and analyze what the problem is telling you. Okay, so the first thing you need to remember is that we're going to look at the horizontal components separately from the vertical components. Remember, horizontal goes left to right and vertical goes up and down. Okay, a horizontally launched projectile is something that starts from some height and is launched and it ends up falling downward. Okay, and that makes a half a parabola shape. Okay, some horizontal components that you need to remember. The first thing is that the launch velocity remains constant. And that's your horizontal initial velocity. That's what VXO stands for. Horizontal initial velocity. Okay? Keeping that in mind, that means there is no acceleration in the x direction, which means it's equal to 0. Okay? The distance that it lands away from where its starting point is called the range. And that's your delta x. That's your total horizontal displacement or distance. Okay, let's talk about the vertical direction. The vertical direction is going to be a little bit more helpful for us for most of the problems that you're going to solve, because that's the direction that is going to be generally used to find the time it takes the object to complete its whole path. Okay? When you're missing time, which most cases you are, and you're usually going to have to find time first, you're going to use either equation 1 or equation 2. It's the same equation, okay? And they're the kinematic equation. Okay, and I'll show you an example of that in a minute. Please keep in mind this is a free fall in the vertical direction, or a dropped object, if you will. That means your initial vertical velocity, Vy0, is 0, and your acceleration in the y direction is negative 9.81 or negative 9.8 or negative 10. Okay, I like to use negative 10. Makes life really easy. Okay, so please keep these concepts in mind while you start solving your problem. Okay, so let's look at a sample problem. A ball is launched horizontally from a height of 250 meters. If the ball lands 300 meters away, what is its launch speed? So the first thing is determine what is given and what is being asked for. So a height of 250 meters, that is your initial position. Okay, and it's landing 300 meters away, so you can automatically conclude that it's going to hit the ground, which is your final vertical position of 0. The 300 meters away is how far away it lands, which is your range, your delta x. Okay, and remember there are two things that you automatically know because you remember your concepts in the vertical direction. Your initial vertical velocity is 0, and your acceleration in the vertical direction is -10. What is it asking you to find? It's asking you to find your v in the horizontal direction at the beginning, your vxo. So in this problem, I do not have time. I need to find time of flight first. So I know my kinematic equations. You can look yours up. Okay, I'm going to use equation number 1 because I have all of the information that is necessary for me to solve using this equation. Okay, fill in your given information. Remember, 0 times anything is still 0. Okay, now we're going to do some algebra. First, I'm going to subtract the 250 from both sides, so I get -250. And then I'm going to apply 1/2 times -10, which is -5. And you don't have to worry about your units carrying through. It all works out in the end, I promise. Okay, now I'm going to divide both sides by -5 to get t squared by itself. And then take the square root of both sides. So the time of flight is 7.07 seconds. If you wanted to round it 7.1, that's fine also. Okay, it just depends on how much of a stickler the person that is grading your papers is. Okay. That does not answer our question. Keep that in mind. We are not done. Okay, the final step is finding the VXO. There's only one equation that I can use in the horizontal direction because there is no acceleration. So that's this equation. And that's your kinematic equation number 2. But since there's no acceleration, the 1/2 at squared goes away. Okay. Plug in your numbers. And then solve for your velocity. And there's your final answer. What if I ask another question about the same problem? So keep all of our givens. But what if I want to know what is the speed when the object hits the ground? So let's take a look at what is happening here, okay? Just to give you a visual. The object, the ball, is going like this. We know that we started 250 meters above the ground and it landed 300 meters away. We just solved for our horizontal initial velocity, right? We know that the time it takes is 7.07 seconds. I want to know what is the velocity when it hits the ground. I like to call it my resultant velocity. So what that looks like in vector terms is this right here. Okay? Now remember, we've learned all about how vectors add. Remember, when you're finding the hypotenuse, we're using right triangle trigonometry. Please keep in mind you cannot use your displacements. Displacement and velocity are completely different variables. Please do not mix them together. So what you need that we don't have yet is your vertical components of this triangle, the velocity when it gets to this point in the vertical direction. So in order to solve that, we're going to use equation number 3 from our kinematic equations. Finding our landing velocity in the vertical direction, we plug in our givens, our known numbers. Okay, now in this equation, our answer is going to come out negative. And that should make sense because it's going down. When I actually start to solve for my my resultant velocity, I'm not going to use the negatives. Negative is direction. I don't need that. Okay? So, solving for my final answer, I'm going to use the Pythagorean theorem, everybody's favorite. Remember, your VXO is the 42.4 and your Vy. Now, remember, it doesn't matter if you use VXO or Vx because the velocity in the x direction remains constant. So your Vx and your VXO are exactly the same. Please make sure you understand that concept. The x direction velocity will never change. When you type all of that into your calculator, you should get this answer. Now, because I asked for speed, I did not require you to find the direction. If I did want to find the direction at which it hits the ground, then I would have to find the angle that it hits the ground at, and then I would use my tangent inverse function. Okay? I hope this video helps.